How many volts are in lightning?
A stroke of lightning discharges from 10 to 100 million volts of electricity. An average lightning stroke has 30,000 amperes.
How accurate is the Old Farmer's Almanac in predicting weather?
The Farmer's Almanac published in Lewiston, Maine, and the Old Farmer's Almanac published in Dublin, New Hampshire, both make predictions about the weather for the coming year when they are published. Each book claims to have secret formulas to predict the weather. The Old Farmer's Almanac claims it has an accuracy rate of 80%. Prior to modern forecasting techniques using radar, satellites, and computer simulation, many people relied on the almanacs for long-range weather forecasts. However, many of the predictions in the almanacs are very general in nature. Such as a 5-day period in November may be predicted to be sunny/cool without a range of expected temperatures or whether it will be sunny each of the 5 days.
When did modern weather forecasting begin?
On May 14, 1692, a weekly newspaper, a collection for the improvement of husbandry and trade, gave a 7-day table with pressure and wind readings for the comparable dates of the previous year. Readers were expected to make up their own forecasts from the data. Other journals soon followed with their own weather features. In 1771, a new journal called the Monthly Weather Paper was completely devoted to weather prediction. The first daily newspaper weather report was published on August 31, 1848 in the Daily News in London. The first daily weather forecast was published in the Times of London in 1860. The first broadcast of weather forecasts was done by the University of Wisconsin Station 9XM at Madison, Wisconsin, on January 3, 1921.
How common are lightning strikes?
Thunderstorms are a very common natural phenomenon. At any given moment, there are 1,800 thunderstorms in progress somewhere on the Earth. Lightning detection systems in the United States monitor an average of 25 million flashes of lightning from cloud to ground every year.
What is the shape of a raindrop?
Although a raindrop has been illustrated as being pear-shaped or tear-shaped, high-speed photographs reveal that a large raindrop has a spherical shape with a hole not quite through it, giving it a donut-like appearance. Water surface tension pulls the drop into this shape. As a drop larger than 0.08 inch, 2 millimeters, in diameter falls, it will become distorted. Air pressure flattens its bottom and its sides bulge. If it becomes larger than 0.25 inch, 6.4 millimeters, across, it will keep spreading crosswise as it falls and will bulge more at its sides, while at the same time, its middle will thin into a bow tie shape. Eventually, in its path downward, it will divide into two smaller spherical drops.
What is the dew point?
The dew point is the temperature at which air is full of moisture and cannot store any more. When the relative humidity is 100%. The dew point is either the same as or lower than the air temperature. If a fine film of air contacts a surface and is chilled to below the dew point, then actual dew is formed. This is why dew often forms at night or early morning, as the temperature of the air falls. The amount of water vapor the air can hold also decreases. Excess water vapor then condenses as very small drops on whatever it touches. Fog and clouds develop when sizable volumes of air are cooled to temperatures below the dew point.
What are the three main groups of rocks?
Rocks can be conveniently placed into one of three groups: igneous, sedimentary, and metamorphic. Igneous rocks, such as granite, pegmatite, rhyolite, obsidian, gabbro, and basalt, are formed by the solidification of molten magma that emerges through Earth's crust via volcanic activity. The nature and properties of the crystals vary greatly, depending in part on the composition of the original magma and partly on the conditions under which the magma solidified. There are thousands of different igneous rock types. For example, granite is formed by slow cooling of molten material within the earth. It has large crystals of quartz, feldspars, and mica. Sedimentary rocks, such as breccia, sandstone, shale, limestone, chert, and coals, are produced by the accumulation of sediments. These are fine rock particles or fragments, skeletons of microscopic organisms, or minerals leached from rocks that have accumulated from weathering. These sediments are then redeposited underwater and later compressed in layers over time. The most common sedimentary rock is sandstone, which is predominantly quartz crystals. Metamorphic rocks, such as marble, slate, schist, gneiss, quartzite, and hornsville, are formed by the alteration of igneous and sedimentary rocks through heat and/or pressure. One example of these physical and chemical changes is the formation of marble from thermal changes in limestone.
What is Doppler radar?
Doppler radar measures frequency differences between signals bouncing off objects moving away from or toward it. by measuring the difference between the transmitted and received frequencies. Doppler radar calculates the speed of the air in which the rain, snow, ice crystals, and even insects are moving. It can then be used to predict speed and direction of wind and amount of precipitation associated with a storm. The National Weather Service has installed a series of NextRad Next Generation Radar, Doppler radar systems throughout the country. They are especially helpful in measuring the speed of tornadoes and other violent thunderstorms.
What is the greatest amount of rainfall ever measured?
The table below summarizes the places that experienced the greatest amount of rainfall and just how much was measured.
Are there trees that predict the weather and tell time?
Observing the leaves of a tree may be an old-fashioned method of predicting the weather. But farmers have noted that when maple leaves curl and turn bottom up in a blowing wind, rain is sure to follow. Woodsmen claim they can tell how rough a winter is going to be by the density of lichens on a nut tree. Trees can also be extraordinary timekeepers. Griffonia, in tropical West Africa, has 2-inch, 5 centimeter inflated pods that burst with a hearty noise, indicating that it is time for farmers of the Accra Plains to plant crops. Trichilia is a 60-foot, 18-meter, tree that flowers in February and again in August, signaling that it is time, just before the second rains arrive, for the second planting of corn. In the Fiji Islands, planting yams is cued by the flowering of the coral tree.
How loud is thunder?
A clap of thunder can be as loud as 120 decibels, which is comparable to the noise at a rock concert, a chainsaw, or a pneumatic drill.
When do thunderstorms occur?
In the United States, thunderstorms usually occur in the summertime, especially from May through August. Thunderstorms tend to occur in late spring and summer, when large amounts of tropical maritime air move across the United States. Storms usually develop when the surface air is heated the most from the sun, 2 p.m. to 4 p.m. Thunderstorms are relatively rare in the New England area, North Dakota, Montana, and other northern states, latitude 60 degrees, where the air is often too cold. These storms are also rare along the Pacific Ocean because the summers there are too dry for these storms to occur. Florida, the Gulf states, and the southeastern states tend to have the most storms, averaging 70 to 90 annually. The mountainous Southwest averages 50 to 70 storms annually. In the world, thunderstorms are most plentiful in the areas between latitude 35 degrees north and 35 degrees south. In these areas there can be as many as 3,200 storms within a 12-hour nighttime period. As many as 1,800 storms can occur at once throughout the world.
Which U.S. hurricanes have caused the most deaths?
The 10 deadliest United States hurricanes are listed below.
What is the color of lightning?
The atmospheric conditions determine the color of lightning. Blue lightning within a cloud indicates the presence of hail. Red lightning within a cloud indicates the presence of rain. Yellow or orange lightning indicates a large concentration of dust in the air. White lightning is a sign of low humidity in the air.
How much does a cloud weigh?
Although they look light and fluffy floating in the sky, clouds actually consist of water droplets and are heavy. A 1 cubic kilometer, 1 cubic kilometer meaning 1 kilometer x 1 kilometer x 1 kilometer or 0.6 miles x 0.6 miles x 0.6 miles. Cumulus cloud has an estimated weight of 2.211 billion pounds, 1.003 billion kilograms. Clouds float because they are suspended on dry air. An equal volume, 1 cubic kilometer, of dry air weighs 2.220 billion pounds, 1.007 billion kilograms. Dry air has a density of 1.007 kilograms/cubic meter while the density of the moist cloud is 1.003 kilograms/cubic meter. Clouds float because they are less dense than the drier air.
Which hurricane in the United States was the most destructive?
The economic loss caused by Hurricane Katrina is estimated at $100 to $150 billion, making it the costliest natural disaster in United States. The death toll for Katrina was less than 2,000, which is significant although nowhere near the death toll of at least 8,000 during the Galveston hurricane in 1900. Katrina made landfall in Plaquemines Parish, Louisiana as a Category 3 hurricane with winds of 125 miles per hour, 201 kilometers per hour. On August 29, 2005, the coastal areas of Louisiana, including New Orleans, Mississippi, and Alabama, suffered extensive damage.
How hot is lightning?
The temperature of the air around a bolt of lightning is about 54,000 degrees Fahrenheit 30,000 degrees Celsius, which is 6 times hotter than the surface of the sun, yet many times people survive being struck by a bolt of lightning. American Park Ranger Roy Sullivan, 1912 to 1983, for example, was hit by lightning 7 times between 1942 and 1977. In cloud-to-ground lightning, its energy seeks the shortest route to Earth, which could be through a person's shoulder, down the side of the body, through the leg, and to the ground. As long as the lightning does not pass across the heart or spinal column, the victim usually does not die.
How fast does rain fall?
The speed of rainfall varies with drop size and wind speed. A typical raindrop in still air falls about 600 feet, 182 meters per minute, or about 7 miles, 11 kilometers per hour. Large raindrops can reach speeds of 16 to 20 miles, 26 to 32 kilometers per hour. Very small raindrops may fall slowly at no more than 1 mile, 1.6 kilometer per hour.
Does lightning ever strike twice in the same place?
Lightning can and often does strike twice in the same place. Since lightning bolts head for the highest and most conductive point, that point often receives multiple strikes of lightning in the course of a storm. In fact, tall buildings, such as the Empire State Building in New York, can be struck several times during the same storm. During one storm, lightning struck the Empire State Building 12 times. Designed as a lightning rod for the surrounding area, the Empire State Building is struck by lightning about 100 times per year during multiple storms.
How is the distance from a lightning flash calculated?
Count the number of seconds between seeing a flash of lightning and hearing the sound of the thunder. Divide the number by 5 to determine the number of miles away that the lightning flashed.
Can weather be predicted from the stripes on a woolly bear caterpillar?
It is an old superstition that the severity of the coming winter can be predicted by the width of the brown bands or stripes around the woolly bear caterpillar in the autumn. If the brown bands are wide, says the superstition, the winter will be mild. But if the brown bands are narrow, a rough winter is foretold. Studies at the American Museum of Natural History in New York failed to show any connection between the weather and the caterpillar's stripes.
Who invented the barometer?
A barometer is a device that measures air pressure. It was invented in 1644 by Evangelista Torricelli, 1608 to 1647. As a student of Galileo Galilei, 1564 to 1642, for a short time. Torricelli was inspired by Galileo's observation that piston pumps can only lift water up 33 feet. About 10 meters, after which point it is impossible to pump the water any higher. Torricelli proposed that air had weight, and therefore, exerted pressure. He tested his theory by filling a dish with mercury, a liquid that is 13.6 times denser than water. A liquid that is denser than water allowed him to use a smaller quantity and a glass tube, which was easier to manipulate. He then took a glass tube 4 feet, 1.2 meters, long glass tube that was open on one end, filled it with mercury, and turned it upside down with the open end beneath the surface of the mercury in the dish. Some, but not all of the mercury, flowed from the tube into the dish. 30 inches, 760 millimeters, remained. The only force that was able to support the mercury in the tube was the weight of the air exerting pressure on the mercury in the dish. The word barometer, which means weight measure, from the Greek baros, meaning weight, and metron, meaning meter, was not coined until 1665 by Robert Boyle, 1627 to 1691. Boyle also changed the design for the barometer by using a shaped tube, thus eliminating the need for a mercury reservoir. The English physicist Robert Hooke, 1635 to 1703. Further improved on the barometer by creating an easy toriad dial display.
Who prepared the first weather map?
The first weather map was prepared by Francis Galton, 1822 to 1911. In 1862, his initial map was prepared by requesting detailed information about the weather in the month of December 1861 from weather stations throughout the British Isles. He plotted the data he collected, drawing the world's first weather map.
How far away can thunder be heard?
Thunder is the crash and rumble associated with lightning. It is caused by the explosive expansion and contraction of air heated by the stroke of lightning. This results in sound waves that can be heard easily 6 to 7 miles, 9.7 to 11.3 kilometers, away. Occasionally such rumbles can be heard as far away as 20 miles, 32.2 kilometers. The sound of great claps of thunder is produced when intense heat and the ionizing effect of repeated lightning occurs in a previously heated air path. This creates a shock wave that moves at the speed of sound. In contrast, the longest rainless period in the world was from October 1903 to January 1918 at Arica, Chile, a period of 14 years. In the United States, the longest dry spell was 767 days at Baghdad, California, from October 3, 1912, to November 8, 1914.
How long is a lightning stroke?
The visible length of the streak of lightning depends on the terrain and can vary greatly. In mountainous areas where clouds are low, the flash can be as short as 300 yards, 273 meters. Whereas in flat terrain, where clouds are high, the bolt can measure as long as 4 miles, 6.5 kilometers. The usual length is about 1 mile, 1.6 kilometers. But streaks of lightning up to 20 miles, 32 kilometers, have been recorded. The stroke channel is very narrow, perhaps as little as half an inch, 1.27 centimeters. It is surrounded by a corona envelope or a glowing discharge that can be as wide as 10 to 20 feet, 3 to 6 meters, in diameter. The speed of lightning can vary from 100 to 1000 miles, 161 to 1610 kilometers per second for the downward leader track. The return stroke is 87,000 miles. 140,070 kilometers per second, almost half the speed of light.
What is a whiteout?
An official definition for whiteout does not exist. It is a colloquial term that can describe any condition during snowfall that severely restricts visibility. That may mean a blizzard, or snow squall, etc. If you get some sunlight in the mix, that makes the situation even worse. It's like driving in fog with your headlights on high beam. The light gets backscattered right into your eyes and you can't see.
What is St. Elmo's fire?
St. Elmo's fire has been described as a corona from electric discharge produced on high-grounded metal objects, chimney tops, and ship masts.
Is a halo around the sun or moon a sign of rain or snow approaching?
The presence of a ring around the sun or, more commonly, the moon in the night sky indicates very high ice crystals composing cirrostratus clouds. The brighter the ring, the greater the odds of precipitation and the sooner it may be expected. Rain or snow will not always fall, but 2 times out of 3. Precipitation will start to fall within 12 to 18 hours. These cirriform clouds are a forerunner of an approaching warm front and an associated low-pressure system.
Why are lightning rods important?
The lightning rod was invented by Benjamin Franklin, 1706 to 1790. Around 1750 following his experiment with the kite and the key. In 1752, Franklin tied a metal key to the end of kite string and flew it during a thunderstorm. Franklin suspected that lightning was a natural form of electricity. He knew that if lightning was electricity, it would be attracted to the metal key. When sparks jumped from the metal key, he understood that electrical current had traveled from the electrified air above down the kite string to the key. This experiment confirmed that lightning is an electrical phenomenon. A lightning rod is often placed on the top of buildings to attract lightning bolts. They are designed to provide a safe path to ground the electricity so that it does not damage the building. In recent years, lightning rods have become even more important because the metal pipes that used to be installed for indoor plumbing and could serve as lightning rods are being replaced by non-conductive PVC pipes.
When was the first weather satellite launched?
The first weather satellite, the television and infrared observation satellite, TIROS-I, was launched by NASA on April 1, 1960. Although the images were not of the same resolution as we have now, they were able to reveal the organization and structure of clouds and storms. One of its accomplishments was to see a previously undetected tropical storm near Australia. The information was conveyed to the people so they could prepare for the approaching storm. It operated for 77 days until mid-June 1960 when an electrical fire caused it to cease operating.
How large can hailstones become?
The average hailstone is about 0.25 inch, 0.64 centimeter, in diameter. However, hailstones weighing up to 7.5 pounds, 3.4 kilograms, are reported to have fallen in Hyderabad state in India in 1939. Although scientists think these huge hailstones may be several stones that partly melted and stuck together. On April 14, 1986, hailstones weighing 2.5 pounds, 1 kilogram, were reported to have fallen in the Gopalganj district of Bangladesh. The largest hailstone ever recorded in the United States fell in Coffeyville, Kansas, on September 3, 1970. It measured 5.57 inches, 14.15 centimeters, in diameter and weighed 1.67 pounds, 0.75 kilogram. Hail is precipitation consisting of balls of ice. Hailstones usually are made of concentric, or onion-like layers of ice alternating with partially melted and refrozen snow, structured around a tiny central core. It is formed in cumulonimbus, or thunderclouds, when freezing water and ice cling to small particles in the air, such as dust. The winds in the cloud blow the particles through zones of different temperatures, causing them to accumulate additional layers of ice and melting snow and to increase in size.
How many fatalities occur each year in the United States due to lightning?
During the years 1980 to 2009, an average of 57 people were killed each year by lightning. The 10-year average, 2000 to 2009, decreased to only 41 people per year. An estimated 300 people are injured by lightning strikes in the United States annually.
What were Benjamin Franklin's contributions to meteorology?
Benjamin Franklin, who is said to have discovered electricity by flying a kite in a storm, made the important discovery that low-pressure systems caused the atmosphere to circulate in a rotating pattern. He made this discovery in 1743, after unsuccessfully attempting to view an eclipse on October 21. There was a storm in Philadelphia at the time, but he later learned that the skies were clear in Boston that day. He then found out that the storm that had been in Philadelphia traveled to Boston the next day. From this information, he surmised that the storm was traveling in a clockwise manner from southwest to northeast. Franklin thus concluded that the low-pressure system was causing the storm to move in this manner. Severe thunderstorm warning, issued when either a severe thunderstorm is indicated by radar or a spotter reports a thunderstorm producing hail 0.75 inch, 2 centimeters in diameter and / or winds equal to or exceeding 58 miles per hour, 93 kilometers per hour. Lightning frequency is not a criterion for issuing a severe thunderstorm warning. It is advisable to seek safe shelter immediately when a severe thunderstorm warning is issued. Tornado watch, issued when conditions are favorable for the development of tornadoes in the area. They normally are issued well in advance of the actual occurrence of severe weather for a duration of 4 to 8 hours. Tornado warning, issued when a tornado is indicated by radar or sighted by spotters. People in the affected area should seek safe shelter immediately. They are usually issued for around 30 minutes. Wind advisory, issued when there are sustained winds of 25 to 39 miles per hour. 40 to 63 kilometers per hour, and / or gusts to 57 miles per hour, 92 kilometers per hour. Winter weather advisory, issued when a low-pressure system produces a combination of winter weather. Snow, freezing rain, sleet, that presents a hazard, but does not meet warning criteria. Winter storm watch, issued when there is the potential for heavy snow or significant ice accumulations, usually at least 24 to 36 hours in advance. The criteria for this watch can vary from place to place. Winter storm warning, issued when a winter storm is producing or is forecast to produce heavy snow or significant ice accumulations. The criteria for this warning can vary from place to place.
What is barometric pressure and what does it mean?
Barometric, or atmospheric, pressure is the force exerted on a surface by the weight of the air above that surface. As measured by an instrument called a barometer. Pressure is greater at lower levels because the air's molecules are squeezed under the weight of the air above. So while the average air pressure at sea level is 14.7 pounds per square inch, 1013.53 hectopascals, at 1000 feet, 304 meters, above sea level, the pressure drops to 14.1 pounds per square inch, 972.1 hectopascals, and at 18,000 feet, 5,486 meters. The pressure is 7.3 pounds, 503.32 hectopascals, about half of the figure at sea level. Changes in air pressure bring weather changes. High pressure areas bring clear skies and fair weather, low pressure areas bring wet or stormy weather. Areas of very low pressure have serious storms, such as hurricanes.
Where is the rainiest place on Earth?
The wettest place in the world is Mawzinram, India. With an average annual rainfall of 467.4 inches, 1,187 centimeters, per year. Second place is Tutunandu, Colombia. With an average annual rainfall of 463.4 inches, 1,177 centimeters, per year. It is estimated that Laro, Colombia receives 523.6 inches. 1,330 centimeters, of rain per year, but this amount has not been verified. The place that has the most rainy days per year is Mount Wailale on Kauai, Hawaii. It has up to 350 rainy days annually.
What is lightning?
Lightning is an electrical discharge occurring in the atmosphere accompanied by a vivid flash of light. During a thunderstorm, a positive charge builds in the upper part of a cloud and a negative charge builds in the lower part of the cloud. The difference between the positive and negative charges increases, generating an electrical field, until the electrical charge jumps from one area to another. Lightning may travel from cloud to ground or cloud to air or cloud to cloud or stay within a cloud. The main types of lightning are, streak lightning, a single or multiple zigzagging line from cloud to ground. Forked lightning, lightning that forms two branches simultaneously. Sheet lightning, a shapeless flash covering a broad area. Ribbon lightning, streak lightning blown sideways by the wind to make it appear like parallel successive strokes. Bead or chain lightning, a stroke interrupted or broken into evenly spaced segments or beads. Ball lightning, a rare form of lightning in which a persistent and moving luminous white or colored sphere is seen. It can last from a few seconds to several minutes, and it travels at about a walking pace. Spheres have been reported to vanish harmlessly, or to pass into or out of rooms leaving. In some cases, signs of their passage, such as a hole in a window pane. Sphere dimensions vary but are most commonly from 4 to 8 inches, 10 to 20 centimeters, in diameter. Heat lightning, lightning seen along the horizon during hot weather and believed to be a reflection of lightning occurring beyond the horizon.
What is petrology and what does a petrologist do?
Petrology is the science of rocks. A petrologist is a person who studies the mineralogy of rocks and the record of the geological past contained within rocks. From rocks, a petrologist can learn about past climates and geography, past and present composition of the Earth, and the conditions that prevail within the interior of the Earth.
What is petrology and what does a petrologist do?
Petrology is the science of rocks. A petrologist is a person who studies the mineralogy of rocks and the record of the geological past contained within rocks. From rocks, a petrologist can learn about past climates and geography, past and present composition of the Earth, and the conditions that prevail within the interior of the Earth.
How are fossils formed?
Fossils are the remains of animals or plants that were preserved in rock before the beginning of recorded history. It is unusual for complete organisms to be preserved. Fossils usually represent the hard parts of animals, such as bones or shells, and leaves, seeds, or woody parts of plants. Some fossils are simply the bones, teeth, or shells themselves, which can be preserved for a relatively short period of time.
How are fossils formed?
Fossils are the remains of animals or plants that were preserved in rock before the beginning of recorded history. It is unusual for complete organisms to be preserved. Fossils usually represent the hard parts of animals, such as bones or shells, and leaves, seeds, or woody parts of plants. Some fossils are simply the bones, teeth, or shells themselves, which can be preserved for a relatively short period of time.
Another type of fossil is the imprint of a what are Indian dollars?
They are six-sided, disc-shaped, twin crystals of aragonite, Caco 3. Which have altered to calcite but retain their outer form. They occur in large numbers in northern Colorado, where they are known as Indian dollars. In New Mexico they are called Aztec money, and in western Kansas they are called pioneer dollars.
Another type of fossil is the imprint of a what are Indian dollars?
They are six-sided, disc-shaped, twin crystals of aragonite, Caco 3. Which have altered to calcite but retain their outer form. They occur in large numbers in northern Colorado, where they are known as Indian dollars. In New Mexico they are called Aztec money, and in western Kansas they are called pioneer dollars.
How old are fossils?
The oldest known fossils are of bacteria that left their impressions approximately 3.5 billion years ago. The oldest animal fossils are of invertebrates that lived approximately 700 million years ago. The largest number of fossils come from the Cambrian period of 505 to 590 million years ago, when living organisms began to develop skeletons and hard parts. Since these parts tended to last longer than ordinary tissue, they were more likely to be preserved in clay and become fossilized.
How old are fossils?
The oldest known fossils are of bacteria that left their impressions approximately 3.5 billion years ago. The oldest animal fossils are of invertebrates that lived approximately 700 million years ago. The largest number of fossils come from the Cambrian period of 505 to 590 million years ago, when living organisms began to develop skeletons and hard parts. Since these parts tended to last longer than ordinary tissue, they were more likely to be preserved in clay and become fossilized.
What is a tektite?
Tektites are silica-rich glass objects, rocks, found scattered in selected regions of Earth's surface. They are generally black, oblong, teardrop, or dumbbell-shaped, and several centimeters in length. They are formed from molten rock resulting when a meteorite, asteroid, or comet fragment impacts Earth's surface. The molten rock is hurled high into the atmosphere, where it rapidly cools into its unique shape and physical characteristics. Their mode of formation is considered indisputable evidence of such impacts. Tektites range from 0.7 to 35 million years in age.
What is a tektite?
Tektites are silica-rich glass objects, rocks, found scattered in selected regions of Earth's surface. They are generally black, oblong, teardrop, or dumbbell-shaped, and several centimeters in length. They are formed from molten rock resulting when a meteorite, asteroid, or comet fragment impacts Earth's surface. The molten rock is hurled high into the atmosphere, where it rapidly cools into its unique shape and physical characteristics. Their mode of formation is considered indisputable evidence of such impacts. Tektites range from 0.7 to 35 million years in age.
What is cinnabar?
Cinnabar is the main ore of the mineral mercury. Its cinnamon to scarlet red color makes it a colorful mineral. It is produced primarily in the United States, California, Oregon, Texas, and Arkansas, Spain, Italy, and Mexico. It is often used as a pigment.
What is cinnabar?
Cinnabar is the main ore of the mineral mercury. Its cinnamon to scarlet red color makes it a colorful mineral. It is produced primarily in the United States, California, Oregon, Texas, and Arkansas, Spain, Italy, and Mexico. It is often used as a pigment.
How does a rock differ from a mineral?
Mineralogists use the term mineral for a substance that has all four of the following features. It must be found in nature, it must be made up of substances that were never alive, organic. It has the same chemical makeup wherever it is found, and its atoms are arranged in a regular pattern to form solid crystals. Although rocks are sometimes described as an aggregate or combination of one or more minerals, geologists extend the definition to include clay, loose sand, and certain limestones.
How does a rock differ from a mineral?
Mineralogists use the term mineral for a substance that has all four of the following features. It must be found in nature, it must be made up of substances that were never alive, organic. It has the same chemical makeup wherever it is found, and its atoms are arranged in a regular pattern to form solid crystals. Although rocks are sometimes described as an aggregate or combination of one or more minerals, geologists extend the definition to include clay, loose sand, and certain limestones.
From what type of stone was Mount Rushmore National Memorial carved?
Granite. The monument, in the Black Hills of southwestern South Dakota, depicts the 60-foot-high, 18-meter-high, faces of 4 United States presidents: George Washington, 1732 to 1799; Thomas Jefferson, 1743 to 1826; Abraham Lincoln, 1809 to 1865, and Theodore Roosevelt, 1858 to 1919. Sculptor Gutzon Borglum, 1867 to 1941, designed the monument, but died before the completion of the project. His son, Lincoln, finished it. From 1927 to 1941, 360 people, mostly construction workers, drillers, and miners, carved the figures using dynamite.
From what type of stone was Mount Rushmore National Memorial carved?
Granite. The monument, in the Black Hills of southwestern South Dakota, depicts the 60-foot-high, 18-meter-high, faces of 4 United States presidents: George Washington, 1732 to 1799; Thomas Jefferson, 1743 to 1826; Abraham Lincoln, 1809 to 1865, and Theodore Roosevelt, 1858 to 1919. Sculptor Gutzon Borglum, 1867 to 1941, designed the monument, but died before the completion of the project. His son, Lincoln, finished it. From 1927 to 1941, 360 people, mostly construction workers, drillers, and miners, carved the figures using dynamite.
What is the composition of the Rock of Gibraltar?
It is composed of gray limestone, with a dark shale overlay on parts of its western slopes. Located on a peninsula at the southern extremity of Spain, the Rock of Gibraltar is a mountain at the east end of the Strait of Gibraltar. The narrow passage between the Atlantic Ocean and the Mediterranean Sea. The rock is 1,398 feet, 425 meters, tall at its highest point.
What is the composition of the Rock of Gibraltar?
It is composed of gray limestone, with a dark shale overlay on parts of its western slopes. Located on a peninsula at the southern extremity of Spain, the Rock of Gibraltar is a mountain at the east end of the Strait of Gibraltar. The narrow passage between the Atlantic Ocean and the Mediterranean Sea. The rock is 1,398 feet, 425 meters, tall at its highest point.
What is the Mohs scale?
The Mohs scale is a standard of 10 minerals by which the hardness of a mineral is rated. It was introduced in 1812 by the German mineralogist Friedrich Mohs, 1773-1839. The minerals are arranged from softest to hardest. Harder minerals, with higher numbers, can scratch those with a lower number.
What is the Mohs scale?
The Mohs scale is a standard of 10 minerals by which the hardness of a mineral is rated. It was introduced in 1812 by the German mineralogist Friedrich Mohs, 1773-1839. The minerals are arranged from softest to hardest. Harder minerals, with higher numbers, can scratch those with a lower number.
Who was the first person to attempt a color standardization scheme for minerals?
The German mineralogist Abraham Gottlob Werner, c. 1750 to 1817, devised a method of describing minerals by their external characteristics, including color. He worked out an arrangement of colors and color names, illustrated by an actual set of minerals.
Who was the first person to attempt a color standardization scheme for minerals?
The German mineralogist Abraham Gottlob Werner, c. 1750 to 1817, devised a method of describing minerals by their external characteristics, including color. He worked out an arrangement of colors and color names, illustrated by an actual set of minerals.
If diamond is the hardest substance, what is the next hardest substance?
Cubic boron nitride, which is the hardest ceramic, is the second hardest substance in the world.
If diamond is the hardest substance, what is the next hardest substance?
Cubic boron nitride, which is the hardest ceramic, is the second hardest substance in the world.
Is it ever too cold to snow?
No matter how cold the air gets, it still contains some moisture. And this can fall out of the air in the form of very small snow crystals. Very cold air is associated with no snow because these invasions of air from northerly latitudes are associated with clearing conditions behind cold fronts. Heavy snowfalls are associated with relatively mild air in advance of a warm front. The fact that snow piles up, year after year, in Arctic regions illustrates that it is never too cold to snow.
Are all snowflakes shaped alike?
Some snowflakes may have strikingly similar shapes, but these twins are probably not molecularly identical. In 1986, cloud physicist Nancy Knight believed she found a uniquely cloned pair of crystals on an oil-coated slide that had been hanging from an airplane. This pair may have been the result of breaking off from a star crystal, or were attached side by side, thereby experiencing the same weather conditions simultaneously. Unfortunately, the smaller aspects of each of the snow crystals could not be studied because the photograph was unable to capture possible molecular differences. So, even if the human eye may see twin flakes, on a minuscule level these flakes are different.
How old are fossils?
The oldest known fossils are of bacteria that left their impressions approximately 3.5 billion years ago. The oldest animal fossils are of invertebrates that lived approximately 700 million years ago. The largest number of fossils come from the Cambrian period of 505 to 590 million years ago, when living organisms began to develop skeletons and hard parts. Since these parts tended to last longer than ordinary tissue, they were more likely to be preserved in clay and become fossilized.
What is wind shear?
Wind shear refers to rapid changes in wind speed and or direction over short distances, and is usually associated with thunderstorms. It is especially dangerous to aircraft.
When was jet stream discovered?
A jet stream is a flat and narrow tube of air that moves more rapidly than the surrounding air. Discovered by World War II bomber pilots flying over Japan and the Mediterranean Sea. Jet streams have become important with the advent of airplanes capable of cruising at over 30,000 feet, 9,144 meters. The currents of air flow from west to east and are usually a few miles deep, up to 100 miles, 160 kilometers, wide, and well over 1,000 miles, 1,600 kilometers, in length. The air current must flow at over 57.5 miles, 92 kilometers, per hour. There are two polar jet streams, one in each hemisphere. They move between 30 and 70 degrees latitude, occur at altitudes of 25,000 to 35,000 feet. 7,620 to 10,668 meters, and achieve maximum speeds of over 230 miles, 368 kilometers, per hour. The subtropical jet streams, again one per hemisphere, wander between 20 and 50 degrees latitude. They are found at altitudes of 30,000 to 45,000 feet. 9,144 to 13,715 meters, and have speeds of over 345 miles, 552 kilometers, per hour.
What is the Coriolis effect?
The 19th century French engineer Gaspard C. Coriolis, 1792 to 1843, discovered that the rotation of Earth deflects streams of air. Because Earth spins to the east, all moving objects in the northern hemisphere tend to turn somewhat to the right of a straight path, while those in the southern hemisphere turn slightly left. The Coriolis effect explains the lack of northerly and southerly winds in the tropics and polar regions. The northeast and southeast trade winds and the polar easterlies all owe their westward deflection to the Coriolis effect.
Who was the first person to attempt a color standardization scheme for minerals?
The German mineralogist Abraham Gottlob Werner, c. 1750 to 1817, devised a method of describing minerals by their external characteristics, including color. He worked out an arrangement of colors and color names, illustrated by an actual set of minerals.
What is the order of colors in a rainbow?
Red, orange, yellow, green, blue, indigo, and violet are the colors of the rainbow. But these are not necessarily the sequence of colors that an observer might see. Rainbows are formed when raindrops reflect sunlight. As sunlight enters the drops, the different wavelengths of the colors that compose sunlight are refracted at different lengths to produce a spectrum of color. Each observer sees a different set of raindrops at a slightly different angle. Drops at different angles from the observer send different wavelengths, i.e., different colors, to the observer's eyes. Since the color sequence of the rainbow is the result of refraction, the color order depends on how the viewer sees this refraction from the viewer's angle of perception.
From what type of stone was Mount Rushmore National Memorial carved?
Granite. The monument, in the Black Hills of southwestern South Dakota, depicts the 60-foot-high, 18-meter-high, faces of 4 United States presidents: George Washington, 1732 to 1799; Thomas Jefferson, 1743 to 1826; Abraham Lincoln, 1809 to 1865, and Theodore Roosevelt, 1858 to 1919. Sculptor Gutzon Borglum, 1867 to 1941, designed the monument, but died before the completion of the project. His son, Lincoln, finished it. From 1927 to 1941, 360 people, mostly construction workers, drillers, and miners, carved the figures using dynamite.
How does a rock differ from a mineral?
Mineralogists use the term mineral for a substance that has all four of the following features. It must be found in nature, it must be made up of substances that were never alive, organic. It has the same chemical makeup wherever it is found, and its atoms are arranged in a regular pattern to form solid crystals. Although rocks are sometimes described as an aggregate or combination of one or more minerals, geologists extend the definition to include clay, loose sand, and certain limestones.
Where do haybubs occur?
Haybubs, derived from the Arabic word hab meaning to blow, are violent dust storms with strong winds of sand and dust. They are most common in the Sahara region of Africa and the deserts of southwestern United States, Australia, and Asia.
What is petrology and what does a petrologist do?
Petrology is the science of rocks. A petrologist is a person who studies the mineralogy of rocks and the record of the geological past contained within rocks. From rocks, a petrologist can learn about past climates and geography, past and present composition of the Earth, and the conditions that prevail within the interior of the Earth.
When was the National Weather Service founded?
The National Weather Service is part of the National Oceanic and Atmospheric Administration, NOAA. It was started on February 9, 1870 when President Ulysses S. Grant, 1822–1885, signed a joint resolution of Congress authorizing the Secretary of War to establish a National Weather Service. Its first official name was the National Weather Bureau. It was renamed the U.S. Weather Bureau in 1891 and became the National Weather Service in 1967. Its mission is to provide weather, hydrologic, and climate forecasts and warning for the citizens of the United States, its territories, adjacent waters, and ocean areas in order to protect life and property and for the enhancement of the national economy. Weather observations are now made hourly and daily by government agencies, volunteer/citizen observers, ships, planes, automatic weather stations, and Earth-orbiting satellites.
What is the record for the greatest snowfall in the United States?
The record for the most snow in a single storm is 189 inches, 480 centimeters. At Mount Shasta Ski Bowl in California from February 13 to 19, 1959. For the most snow in a 24-hour day. The record goes to Silver Lake, Colorado, on April 14 to 15, 1921, with 76 inches, 193 centimeters, of snow. The year record goes to Paradise, Mount Rainier, in Washington, with 1,224.5 inches. 3,110 centimeters, from February 19, 1971, to February 18, 1972. The highest. Average annual snowfall is 241 inches, 612 centimeters, for Blue Canyon, California. In March 1911, Tamarack, California, had the deepest snow accumulation over 37.5 feet, 11.4 meters.